Okay, so today we're going to start talking about measurement, not just the conversions that we did in the last unit, but we're going to talk about the actual process of measuring and how it works. We talked about the units and where they came from, inches and all that stuff. And we talked a little bit about how the ruler came about, where somebody finally just took a stick and marked out and labeled, 1 inch, 2 inches, and so on. So they didn't have to move it and count every time. And it had a drastic change in the accuracy of our measurements, because now we didn't have that error every time we moved the little piece. There's a little bit of error introduced. So by having it marked out like this, it was a lot more accurate, a lot more precise. And of course, the way this worked is you had the end here that was basically your zero end or your starting point. You would take a piece, you'd line it up there, and wherever it ended up was its measurement. So we look at this, it comes right here, that's closer to the 3, so this would be measured as 3 units, whether that's inches or centimeters or whatever. Let's say it's inches for now. Let's say I have this one. Well, this one would also be measured as 3 inches. But looking at those two, they're obviously not the same length. So this is what we call precision. Precision is the ability of a measuring device to distinguish between two things of similar size or similar dimension. This measuring device is not precise enough to distinguish between the blue and the red lines. How do we make it more precise? Well, what they did was just this. They put in marks at the halfway point. Now in this case, both of them are still closer to 3.5. So it's still not precise enough to distinguish between them. So they cut each of those in half to make quarters. Now at that, the blue one's still closer to 3.5. The red one is slightly closer to the 3 1/4. So this measuring device is now finally precise enough to distinguish between those two objects. That's something we call the degree of precision. And the degree of precision is actually measured as the smallest division on the ruler. So the degree of precision of this measuring device is 1/4 inch, because the smallest division on it is 1/4 inch. Now you'll notice neither one of these is exact. The blue line is not exactly at 3.5. In fact, anything that would have gone from here over to here would have been called 3.5. That goes halfway to the next line, the next division of the ruler. So there is a potential error, possible error, built into every measurement. And that possible error is equal to 1/2 of the degree of precision. So in this one, since the degree of precision is 1/4, 1/4 divided by 2, or 1/4 times 1/2, is 1/8. So the potential error here is 1/8 of an inch. Every measurement we make could be off by 1/8 of an inch. So like this 3 1/4 here is technically 3 1/4 inch, plus or minus 1/8 of an inch. So let's give you a ruler here. So there's my 1 inch mark. First of all, what is the degree of precision? We got to figure out what each of those divisions stands for. This is obviously the halfway point, so all we have to do is count one side of it. So we've got 1, 2, 3, 4, 5, 6, 7, 8, which means there's 16 divisions, which means each division is 1/16 if this is 1 inch, right? So it's a 1/16 of an inch. What's my possible error? what's half of a 16th? 1/16 times 1/2 or divided by 2 is 1/32 of an inch. So let's say I take a measurement and I get a measurement of 4 1/4 inches. What that's really saying is 4 1/4 plus or minus 1/32 of an inch. Plus or minus that possible error. Which means that this could really be, 4 1/4 is 8/32. So this could mean that it could be anywhere from 4 7/32 up to 4 9/32 of an inch. It's implied that even though we're saying 4 1/4, that the actual measurement is somewhere between those two numbers. Does that make sense? So in standard units, since we're using halves and fourths and stuff like that, we have to know something about the ruler. We have to know, does the ruler go to the nearest fourth or the 16th or whatever to get a degree of precision and a possible error out of it. In the metric system, it's implied by the numbers. For example, is there a difference between those two measurements? Well, numerically, no. 2.3 and 2.30 are the same number, have the same value. But this 0 here implies something about that measurement. The 2.3 implies that its degree of precision is only to the nearest 0.1 centimeters, because the last digit of the measurement is in that tenths place. It's 1/10 of a centimeter, 0.1. This one is implying that the degree of precision is 0.01 centimeters, because it has a digit in that hundredths place, 0.01. So this is implied to have a much more precise measurement. So having that 0 there or not is very important to the measurement. What it's telling us is that we have a possible error of, this one will be plus or minus 0.05 centimeters, just half of that. Dividing this by 2 would be plus or minus 0.005 centimeters. So this one here is implying that this is anywhere from 2.25 centimeters to 2.35 centimeters. This one is implying that it's anywhere from 2.295 centimeters to 2.305 centimeters. Make sense? Okay. I can't say a whole lot, so I'm just going to hope that that was enough that you understand what we're doing. So I'm going to leave it at that and give you, in your book, page 173, exercise 4.2. 1 through 29, yeah. Did you get that down, Jason?
Yep.
Okay.